Greetings, children, and welcome back. Today, we're doing trigonometry. So we're starting trigonometry, which is a study of the star. No, that's not correct. It's a study of triangles. So trigonometry actually means triangle measurement. That's what the word trigonometry means. So trigonometry is based on triangles, and we're going to be studying right triangle trigonometry, which is a special type of trigonometry that just focuses on right triangles. So today we're going to learn what your book calls the Pythagorean Rule. Most of the time you'll hear it called the Pythagorean Theorem. So if I refer to it as the Pythagorean Theorem, just know that it's the same thing. It's just that your book calls it the Pythagorean Rule. So the Pythagorean Rule is named after a famous mathematician from ancient Greece named Pythagoras. And Pythagoras studied geometry and all kinds of math. The Greeks were specifically interested in math and collecting the math that had already been known and writing it down, which is a really important part of our learning, is being able to look back and see what was already learned so that we have somewhere to start that's further ahead. I believe it was Isaac Newton who said, "If I've been able to see further, it was because I stood on the shoulders of giants," meaning there were great mathematicians before him, and then he was able to accomplish even more than they did because they had already laid the foundations for the math that he knew. So keep that in mind as you learn. It doesn't just apply to math, it applies to all kinds of things. And being able to start further ahead than your predecessors is a huge gift. So anyway, the Pythagorean Rule refers to the sides of a right triangle and being able to find the length of a side when you know two of the other sides. Today we're going to be focusing on the hypotenuse. So let's talk about a right triangle and review the parts real quick. So in a right triangle, you have a right angle and then two acute angles. So when we label it, we label the angles, where the angles are, we label those with capital letters. So let's say we have A, B, and C. So the opposite sides are also labeled A, B, and C, but we use lowercase letters. So the length of this side down here would be A, the length of this side over here is B, and the length of this side is C. Now, in a right triangle specifically, these different sides of the triangle have different names. This is called a leg. This one is also a leg. The two legs make up the right angle. And then the side that's opposite the right angle is the longest side in a right triangle, and it's called the hypotenuse. So, the hypotenuse. And it looks like it's spelled hypotenuse. So, hypotenuse. Okay, so a lot harder to pronounce than the word leg, but we have two legs and the hypotenuse. And the legs are usually labeled A and B, and the hypotenuse is labeled C. Remember, we use lowercase letters to talk about the length of a side. We use capital letters to name the angles in the triangle. So, the Pythagorean rule says this. It says that if you know the length of the two legs, then you could find the length of the hypotenuse, and the formula looks like this. C squared equals A squared plus B squared. In the fancy math terms, it says that the square of the hypotenuse is equal to the sum of the squares of the legs. So just remember this, C squared equals A squared plus B squared. A and B are legs. C is the hypotenuse. So let's say that we had a triangle over here, and we know that this one's 2, or 3 rather, and this one's 4. So we're trying to find C, which is the hypotenuse, and we know one of the legs is 3, the other leg is 4. So this is how we would write our formula. And you need to write this down and show your steps as you're working these out. That way, if you make a mistake, you can go back and check. So c squared equals 3 squared plus 4 squared. Remember, squared means we're multiplying this number by itself. So we use it as a factor twice. So that means c squared would equal 3 squared, which is 9, and 4 squared, which is 16. Following the order of operations, now we can add, and we get 25. Now, this says c squared equals 25. We don't want c squared, though. We want c. So in order to find c, we have to take the square root of both sides. So we'll take the square root of c squared and the square root of 25. The square root of c squared is just c. So whenever you take the square root of something that's already squared, you just get that letter or number. The square root of 25, if you recall, we learned these earlier in the year, the square root of 25 is 5. Remember, there's a chart in the back of your book that has a table of squares and their square roots. So if you forget what a square of a number is or the square root of a number is, you can check in that chart. So this says that c here is 5. So that means that this triangle has a leg that's 3, a leg that's 4, and a hypotenuse of 5. Okay? So when we're working these out, you're always going to set it up like this. Write the formula, or the rule here, c squared equals a squared plus b squared. Substitute in the parts you know. A was 3, b is 4. Use the order of operations here to simplify. And then when we get to this step, we took the square root of both sides, and we found the value for c. Let's try another one. So let's say we have a triangle here. And remember, this only works for right triangles because right triangles are the only ones with a hypotenuse. So here, let's say that this one is 3 and this one is 7. And we're trying to find the hypotenuse again. So c squared equals 3 squared plus 7 squared. So we would have c squared equals 9 plus 49. So c squared equals 9 plus 49. Let's see, that would be 58. And then we would take the square root of that. So square root of c squared and the square root of 58. Well, we won't get an exact answer here, so we're going to use our squiggly equal sign, which means approximately equal to. And this is where you'll look in the very back of your book. And you'll find your chart. Let me see which page that's on. It's on page 419. And we go to 58, and it says that the square root of 58 is 7.616. So this is approximately 7.616. And depending on the directions, you may need to round that. So let's take a look at the directions for your homework. It says, find the length of each hypotenuse. So it doesn't tell us to round. Oh, and then at the bottom, there's a different section that says, round each answer to the nearest tenth. So if we were going to round this to the nearest tenth, that would be c is approximately 7.6. So 7.6 would be our answer here because we rounded it to the nearest tenth. Remember, the tenths place is the one right after the decimal. So we rounded it to one place after the decimal. So let's take a look. This one is very similar. So this is 7.6. Very similar to the one we did before it, except this step didn't come out quite as nicely because it wasn't square root of a perfect square like 25. So we set up our formula. We substituted in the parts we knew. A here was 3 and B was 7. 3 squared and 7 squared. 9 plus 49 is 58. And then we took the square root of both sides of our equation, and we get c is approximately 7.616. And then we rounded it because our directions say round to the nearest tenth. So that's all there is to using the Pythagorean rule to find the hypotenuse of a triangle. Next time, we're going to use the Pythagorean rule to find one of the legs. It's pretty exciting stuff. So stay tuned. We'll see you next time.